Hello friends, I welcome you all again in the engineering geological exercise. Today we will discuss about the geological logging for drift. Some people say this is 3D geological logging, some people say underground mapping for the drifts. So basically this is geological logging for drift, or you can call it with different name also. So drift is very important structure for any mega structure. For example, if suppose that we are going to construct a underground powerhouse, so we have to construct a drift to see the rock characteristic features and to conduct the in situ test for the rock in the drift for the stability of our structure. Same thing, drifting can be do for the some other structures like mega cavern facility. That cavern facility may be used for the storage of something like oil, gas, etc., etc., or maybe for the underground caverns for defense purposes or some other purpose also. So basically drift is very important, and we prepare the geological logs for the drift to know the rock condition to stabilize our future structure on that. So let's discuss different geometrical relationship with the drift direction and the joint relationship. Okay, so here we have a drift log here. I know, I am thinking that you are very aware about the terminology with the logs. So this is the left invert, this is the left SPL, and this is the center line of the drift. Okay, so here you can see this is the drifting direction 268. This is drifting direction 268. So here foliation joint is almost parallel to the drifting direction. So what will be the trace on the drift log? Here you can see this is the 360/50 foliation direction. This is the dip direction. Actually, this is not a strike. So if we calculate the strike, this will be approximately 270. So this is almost parallel to our drifting direction, that is 268. So the trace of the foliation joint will be parallel to our drift direction. So as you can see, the foliation is almost parallel to the drift. Okay, here also in the right invert you can see this is the foliation. So you can see this is almost 360 direction, and you can see again the foliation is parallel to the drifting direction. Here we collect each and every joint data, and we try to plot each and every joint, shear zone or quartz vein, etc., etc. You can see this is the shear zone and the groundwater condition in the form of the dripping amount. So we calculate or measure the dripping amount and give a appropriate symbol at a designated place wherever we are getting the dripping. Okay, so this is the parallel case when we plot the joint that is almost parallel to the strike of the drifting direction. So you can see the foliation joint is almost parallel. Okay, here that's why the foliation symbol, this is a nice symbol. So you can see the nice symbol is almost parallel to the over drifting direction, as you can see here. Now we have a case where we are getting the means some angle to the drifting direction of the foliation joint as well as some other joints also. So here you can see this is the drifting direction 345 degree. Okay, and we have the foliation amount, this is 345/58. So this is the dip amount. So if we calculate the strike of this foliation joint, that will be 255. So this foliation joint make an angle to the drift direction. That's why then what we have to do, we have to keep our log or graph sheet in the drift in the appropriate direction and mark the joint transaction point where it intersect to the left invert. Then we have to see on the left SPL also. Then we have to see the intersection in the at the center line, then at the right SPL, then invert. Then we have to match this with the sketch. So this is the trace of the joint. So you can see if the angle is increasing, if angle is maximum, it will show the maximum termination and the minimum persistence in the drift log. But when the angle is increasing, means less than 90 degree, and increasing or decreasing towards the 0 degree, moving towards the 0 degree, the expansion of the joint or any shear zone or any discontinuity will be great here. So this is the persistence So it's depend on the angle of the discontinuity, how it appear on the log. So you can see this joint here, this is basically open joint here. So the data of this joint is 180 degrees, so it's dipping towards 180 degree. Okay, so if we calculate the strike, it will be approximately 90 degree. So this is means, and it's making an angle because the dip amount is 38 degrees, so it's not so high, that's why it's showing long persistence at the log. Okay, that's why. So if the angle is steep, persistence on the graph sheet will be less. Same thing here, you can see we have some small joints also, those has very less persistence here. This is 212 and 66 degree. So you can see the persistence from the left inward to the center line, and the angle is 66 degree. That's why it's showing the steep, and the angle between the strike of the joint and the drifting direction is also high. So if the angle between the strike of the drift and the strike of the joint or discontinuity will be high, that means the presentation or trace of that particular discontinuity will be less at the log. Okay, beside this, we have to plot all the plane faces on the graph sheet, as you can see here. So basically, if you want to collect the good data, you have to be very good sketchy person. Okay, so you have to learn how to prepare a good sketch. So basically, this is a sketching skill. So you can see here, this is a plane here also. So with this plane, trace of the plane, we have to collect the orientation also for each and every plane. Okay, so and then you can see here, this is a shear seam. So you can see the thickness of the shear is also mentioned here, 10 to 15 centimeter thick shear with feeling also. Feeling is very important for the shear zone. So you can see here, we have written sandy material feeling. So we have to mention during the logging feeling also. Feeling is very important because feeling if affect the shear sense of the wall. Okay, so what type of data we generated from this logging, you can see here. So we have to collect each and every joint set at every 10-meter interval, and we have to collect the mean of the average orientation, spacing, roughness, aperture, type of filling for the every set. Then we have to finally calculate the RMR as well as the Q value. Some people calculate the GSI value also. So that's depend on your task, whether you want to calculate the RMR only, or you go for RMR and Q value, or you go for RMR, Q value and GSI also. So this is the end of the video. I hope you will like it and it will be beneficial to you. Thank you very much.